Real good. Okay, so today we're looking at graphing quadratic functions. Right? We have said that quadratic functions, or quadratics in general, are things that have a degree of 2, an exponent of 2. Okay? So a quadratic is a function that can be wrote, that can be written in the form y equals ax squared plus bx plus c. Okay, the only rule is that a can't be 0, because if a is 0, then that makes the x squared go away, and then it's no longer quadratic, it's a linear. Okay? We said when we were talking about solving quadratics by finding the roots or zeros, right, we were plugging them into the graphing calculator. We said that if it were to equal 0, we could replace that 0 with a y, right, because we knew on the x-axis our y value would equal 0. So that's all we're doing, is taking those same functions that we've been talking about, but now instead of having it equal to 0, we now have it equal to y, where we have corresponding input and output values, just like we did with functions first trimester. When we graph a quadratic function, it does not matter what other things are happening. If it is a degree of 2, we always get a U-shaped graph that is called a parabola. Strange word, I don't know why, but there it is. So those U's that we were seeing when we were plugging it into our graphing calculators are called parabolas, and that's what we will get every single time that we graph in this unit for quadratics. Okay. There are a couple different ways that we can graph quadratics. So we're going to look at some information today. We're going to look at some information tomorrow. But the reality is that we can always graph a function, any function, whether it is quadratic or cubic or linear, it doesn't matter. We can always graph a function by having a table and plugging in some input and output values. That's what we learned first trimester. Right? So if you're taking a test, a state test, a test for a class, and you're just like, oh shoot, this is asking me to graph and I completely forget, this is an option you can always use. Okay, I'll have second year algebra students who come to me and they're saying, Mrs. McKinney, can you help me with this graphing of conics? I'm like, oh man, it's been forever since I've looked at those formulas. And so sometimes I have to do some plugging and chugging to go, okay, yeah, this is what the formula tells us to do. Okay, it is that most basic structure that always gives us points on the coordinate plane. Now, you would have to plug in a lot of points to find the ones that are actually going to give you that curve to make sure we see the whole thing. I'm going to tell you exactly what points we're going to plug into our table right now. 5 of them. We're going to plug in -2, -1, 0, 1, and 2. And then just like any time we're plugging something into a function, right? This is our input value. This is our domain. We take that and we plug it in for x. So if this is the function that I want to graph, I'm going to take my x value and I'm going to plug it in here. Right? So I want -2 squared. But since I want all of -2 squared, especially if you're using a calculator, we want it in parentheses. Okay, so -2 squared is what? 4. Then we'll plug in -1. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, then just like anything else, every time we talked about functions first trimester, we can always think about this as an ordered pair. So this is now the ordered pair, -2, +4. Which means I can go over here to my coordinate plane and I can plot the point -2, +4. Right, my next point is -1, +1. Zero, comma, 0. One, comma, 1. And then 2, comma, 4. This can be a little bit deceiving and look a little bit like a V, like those absolute value graphs that we had first trimester, but that's not happening. Okay, because this has an exponent of 2, we know it's a quadratic. So this is actually a curve happening here. So don't make it like a V, make it like a curve. Where both of those sides keep going up and slightly getting wider and wider and wider as we go. So here's what we need to agree with right now. We should agree that a quadratic is something with a degree of 2. When we graph it, we get a U-shaped graph called a parabola, and that we can plug in points to get a graph. Do we agree with all those statements? Any questions about that? Okay, now we need to talk about some definitions here. We got some new vocab going on with quadratics. Okay. A quadratic has something that we call an axis of symmetry. Sometimes this is called a line of symmetry. And so sometimes you'll see it abbreviated as the LOS. The axis of symmetry is the line that divides the parabola into 2 matching halves. Now, whether you remember this or not, you've been finding an axis of symmetry since like 4th grade. Okay? Your teacher maybe didn't use that word exactly. Okay, but you would take figures like squares or circles and you would have to draw a line in that divided it exactly in half. So one of the most common ones that my students use, right? We take a piece of paper, we fold it in half, we cut, and then we get a heart, right? We only had to cut one time with it being folded in half because that fold crease is the axis of symmetry, right? One side is an exact duplicate of the other. So that happens with parabolas, right? We can fold a parabola in half, okay, and it's an exact duplicate on each side. Okay. The vertex, another point that we can talk about on the parabola, is the high or low point on the graph. So when we talked about graphing linear functions in Algebra 1-1, we talked about a line that would go in both directions for forever. A quadratic doesn't do that. It does have 2 sides, but those 2 sides go in the same direction for forever, which means there's a point that that parabola doesn't exist past. Sometimes it's at the top, sometimes it's at the bottom. Okay, if A is greater than 0, then the graph is going to open up. Okay, and the graph will have a low point that we call a minimum. numbers are greater than 0? Positive numbers. So this says if A is positive, the parabola opens up. An upward looking parabola looks like a U, up, U. And the only type of A we're going to look at today is if A is positive 1. If A is less than 0, then the graph is going to open down. And the graph will have a high point that we call a maximum. Okay, so down has an N, the parabola opens the same direction as an N. What kind of numbers are less than 0? Negatives. So this is talking about negative numbers. And the only negative number that we're going to look at today is negative 1. That doesn't mean that A can't be other values. Okay, but for today, we're only looking at positive 1 and negative 1 for A. Okay, so these are just some terms we need to know about parabolas in general so that we can now graph them. Okay. Just like when we graphed linear functions, right, we talked about that we could graph them by plugging in input and output values, and that was our functions unit. But then we said, oh, by the way, there's also some shortcuts, right? You could graph in slope-intercept form, you could graph in point-slope form, you could graph in standard form, right? We talked about 3 different options. That's the exact same process we're going through here. Here is one format that we can use as a shortcut to graph quadratics. Right? You can always plug and chug a value. Or you can see what format it's in and pick from the different options we're going to look at. Today we are looking at vertex form. Okay, this form right here is called vertex form. It's still a quadratic because we have an exponent of 2. When we are in this format, we can identify all of the key pieces that we need to be able to graph the quadratic. Okay, x equals h is going to be our line of symmetry, or our axis of symmetry. Okay, that's going to be what chops the parabola in half. Our vertex, which is the higher low point, we are going to be able to find by identifying h and k. Now, you really have to think back in your brains here. But notice how this h has a subtraction sign? Just like in point-slope form, that subtraction is part of the formula, not part of the value. Okay, so the h is negative in the formula, and the k is positive. This is going to tell us something in just a second, but I'm going to let you write so I can scroll down. You got that? Okay, that tells us that we're always going to have to take the opposite sign to find h. Just like in point-slope form, that subtraction symbol, right, when we pulled out that ordered pair, we always had to take the opposite sign because the subtraction was part of the formula. Same thing is happening here. Okay. H is going to change, oh, sorry guys, I should probably flip forward. H is going to change the horizontal movement of the graph. It's going to tell us how much to move right and left. If h is positive, we are going to move right. And if h is negative, we are going to move left. K is going to change the vertical movement of the graph. If K is positive, we are going to move up. If K is negative, we are going to move down. Those should hopefully make sense. That's kind of always what it's been, right? Positive numbers are to the right or up, negative numbers are to the left or down. Usually at this point, my students are kind of like, okay, so what do I do with any of this? You just dumped a lot of info on me. And you're right, I did. Okay, so we're going to go through a couple examples here, but you're really going to have to practice some on your own for you to kind of go, oh, that makes sense, right? So let's look at a couple here and talk about what we're going to do with it. If I can fit that. So if we put this all together, we now know this information. We know it should be a U-shaped graph. We know we're going to talk about if it opens up or if it opens down. We need to consider a vertex and a line of symmetry. Okay. Here's an equation given to us in vertex form. We said vertex form, its general form was y equals a times x minus h squared plus k. So when we go to graph this, we are going to look at the problem that's given to us. And just like we did with slope-intercept form or point-slope form, right, we're going to find those key pieces, those key letters. Okay, so what does a equal in this function that's above? Right, I see somebody, 1. There's a 1 here, we just don't see it, right? So a equals